Hello everyone. In previous lectures, we have discussed the classification of signals. In this lecture, we will discuss the classification of systems. It includes continuous time systems and discrete time systems, linear systems and nonlinear systems, time invariant systems and time variant systems, causal system and non-causal system, stable systems and unstable systems. First, we'll discuss the continuous time system and discrete time system. If the input signals and output signals are both continuous time signals, the system is termed as continuous time system. Similarly, if the input signals and output signals of the system are both discrete time signals, the system is termed as discrete time system. Such as these circuits, composed of resistors, inductors, the system is the continuous time system. For these circuits, composed of resistors, contacts, the system are discrete time systems. As we all know, first generation communist system are continuous time system. The fourth generation communication system is discrete time system. Now we will discuss the linear system and the nonlinear system. For the linear system, with the properties of superposition and homogeneity in terms of the system input signal and output signal. For the continuous time system that is initially at rest, if the input signal multiplied with constant k, its output signal also multiplied with a constant k. The system is with the homogeneity. If the superposition of input signal x1t and x2t, its output signal is with superposition of y1t and y2t. Only if a system satisfies the properties of superposition and homogeneity, the system is defined as a linear system. For the continuous time linear system that is initially at rest, we can express it in this way. Here, alpha, beta are constant factors. Similarly, we can define the discrete time linear system. If the input signal is x1 of k, its output signal is y1 of k, and its input signal x2k, its output signal is y2k. Then the signal alpha times x1k plus beta x2k, its output signal is alpha times 1k plus beta y2k. The system is a linear system. In summary, for the linear system, it should satisfy both the property of superposition and the property of homogeneity. For the nonlinear system, it violates either the principle of superposition or the principle of homogeneity. For example, consider the continuous time systems described in these equations. Let's determine its linearity. For the first system. Let's determine its homogeneity. According to this relation between input signal and output signal, we can get this result. Obviously, this expression doesn't equals k times y of t. So the system violates the principle of homogeneity and is therefore a nonlinear system. For the second system, let's first determine its homogeneity. According to the relation between input signal and output signal, we can get this when the input signal become k times x of t, we can get its output signal. This result doesn't equal k times y of t, so the system is nonlinear system. For this system, let's determine its homogeneity first. According to the relation between input signal and output signal for the system, we can get this result for this signal k times xt. This result equals k times yt. So the system satisfies the principle of homogeneity. Let's determine its superposition. According to this relationship between input signal and output signal, we can get these equations. When the input signal is x1t plus x2t, its output signal is also equals y1t plus y2t. So the system also satisfies the principle of superposition. The system both satisfies the superposition and homogeneity. So the system is a linear system. The system is a linear system. You can think it after class. This system is a linear system. You can try it after class. For this system that is a not linear system, you can verify it after class. Determine these systems the linearity. For this is an integrator. This system is a unit delayer. First, we have this composite signal. Substitute this composite signal into this equation. We can get this result. We can move alpha and beta outside this integral. We can get this equation. This part equals y1 of t. This part equals y2 of t. So we can get this result. So the integrator system is linear. Similarly, we can have this composite signal x of k. Substitute this signal into this equation, we can get this result. This part corresponding to y1 of k, this part corresponding to y2 of k. We can get this result. So, in unit delayer, system is linear. The system is described in this differential equation. Determine its linearity. The answer is a linear system. You can try it after class. Now we can consider the linearity of a resistor, a capacitor, and an inductor. If the current I of t is the input signal, voltage V of t is the output signal. This is the relationship between the input signal and the output signal for the resistor, capacitor, and inductor. According to the discussion we have known, for these systems, they are linear systems. So these systems are linear systems. Here is the proof for the resistor. You can think it after class. Here is the proof for the capacitor. And this is the proof for the inductor. You can think it after class. All the electric systems consisting of resistors, capacitors, and inductors are linear because the resistor, capacitors, and the inductors are linear systems. In this lecture, we have discussed the linearity of system. That's all for this lecture. See you later.